Let's quickly see the memory organization of 8051 microcontroller. Just to get an idea what is RAM and how the variables are stored in RAM. 8051 microcontroller contains 128 byte of RAM, range from 00H to 7FH. First 32 byte are reserved for register bank and stack. Then next 16 byte are reserved for bit addressable read-write memory, and then 80 bytes from 30H to 7FH is reserved for read-write storage, or also called as scratchpad. Global variables are stored into this memory area, while the local variables get stored into either register or stack, this memory area. 8051 microcontroller got 4 kilobyte of ROM, stand for read only memory, starting from address 000H to 0FFFH. Read only memory is also called as a code memory because the code written under void main function and any other function gets stored into these memory locations. Similar to 8051 microcontroller, every other microcontroller or microprocessor got two memories. One is RAM, random access memory, and other one is ROM, read only memory. RAM normally used to store variable data, and ROM are normally used to store code. Program variables: int xyz. Using this statement, we are creating three variables xyz, which is of type int. Character AB, this statement will create two variables a and b, which is of type char. Space for variables may be allocated in register, RAM, or ROM. If we write like this, int x equals to 5, in that case, that particular variable will get stored to ROM memory location. There are two types of variables, automatic and static. Normally, automatic variables get stored into registers and static variables get stored into RAM. Let's discuss about automatic variable. Automatic variables we declare within function or procedure. This variable is visible only within that function. Space for this variable is allocated on system stack when the procedure is entered and deallocated to reuse when the procedure is exited. If only one or two variables are used in program, then the compiler may allocate them to register within that procedure instead of allocating memory. The value of automatic variables are not retained between procedure calls. Here is the example, int I, j. Here I and j both are automatic variables. The visibility of these variables are limited to this function only. So when you exit from this function, the value of I and j become 0. So every time you entered into this function, you have to initialize the value of I and j. Static variables. Static variable retain the value for use throughout the program in RAM location. We can declare static variables within or outside the function. If we declare static variable outside the function, the variable becomes global in scope, that is, known to all functions of program. For such variable declaration, we use normal declarations. Here is the example, int count. If we declare static variable within function, then we have to use static keyword before the variable definition. This variable is local in scope, that is known only within the function. Here is the example, static int count. Here is the code that explains the initialization of global variable count. Here we haven't used static keyword. Since this variable is inside the void main loop, hence we don't need to write static in front of int. Here is the another piece of code where this function is not the void main function or the main function. Here we have declared variable j as static int. Since we want to make this variable j to get stored into fixed RAM location, I have to use here word static.